Welcome to the Education Innovators Podcast. I'm Eric Byron, and it is my privilege to host this show where I get to talk to folks from all over the world who are education thought leaders and innovators. We'll hear inspiring stories from educators, EdTech founders, AI experts, and others who are fearlessly innovating and delivering unique learning experiences. I'm glad you're here. Let's get started.
Inspired by biological intelligence, right? Our own brains. And that's the case I make for like why I believe combining these two paradigms, the statistical and the symbolic paradigms, is such a promising avenue to at least explore, right? I think, I'm not saying for sure this is going to work, but like you said, there's a little bit of bravery involved, right? To try something different from what the majority of AI is doing right now.
My guest today is another fascinating character. Haihao Liu is a brilliant researcher who's working on a theory for a hybrid AI model that may allow us to develop a more accurate and adaptable AI-powered math tutor. Now, the discussion is a bit technical, but it's loaded with some great background and history on the development of AI. And Haihao does a wonderful job of explaining his theory and this hybrid model that he's working on and how that may be applied to math tutoring. Keep listening. Welcome to the Education Innovators Podcast. I'm Eric Byron, and today I have with me Haihao Liu. And he is currently serving as the Education Director for the Asian Community Development Center, which is a growing US-based nonprofit with a mission to empower the Asian American community. He is passionate about education equity and reform. He's pursuing a Master of Education in Learning Design, Innovation, and Technology at Harvard, and he's currently on hiatus there. He also graduated from Rice University, summa cum laude, and Phi Beta Kappa in 2018 with a dual degree, a BS in Materials Science and Nano-Engineering, and a BA in Mathematics. He worked from 2019 to 2022 as an NSF Graduate Research Fellow and PhD candidate at MIT, researching machine learning for making new materials with LLMs before they were large, and embedding domain knowledge explicitly into the ML model architecture itself. And I'm not done yet. His current nonprofit startup is Eternity Education, and it aims to combine the bleeding edge of AI, including knowledge graphs and multi-agent IL plus RL, and we're going to explain that later, with modern understanding of neuroscience and learning science to ultimately transform how students learn in this century and beyond. Oh, my gosh, so much stuff there and so much education. It's just fascinated with, well, people who are so smart and academic, with Rice and MIT and Harvard and this, education director of the Asian Community Development Center. Now you've got an EdTech startup. You've got a lot going on. And
I do.
And I also want to point out, right, so you grew up in China, but you're clearly kind of a global citizen, and you're currently in London. Is that right?
I am. I've been in London for the past few months since February, but that's a bit of a random thing. My brother was doing exchange here, and so I came here because I have a place to stay. So it's more of an extended visit, but I do really like it here. And if I have the opportunity, to either do a degree in the UK or other opportunities, I would love to be here.
Yeah, but you just did a talk or something.
Yes, that was just on Monday, actually. Yeah. So this week was London Tech Week, which is it only started, I forget how many years ago, but it's a very big event now. Top business and tech and government leaders gather in London. There was a keynote from Jensen Huang of NVIDIA. Anyway, the panel the side event I was on was the Asia Summit. And so there were government officials and business leaders from across Asia, including several ministers and vice ministers of like national level from Malaysia, Indonesia, and Philippines. And we were talking about the theme was preparing Asia for the AI transformation. And I was really honored to be given this platform to share a little bit of my thoughts. And I also learned a
Yeah.
ton, of course, from
Well, of
everyone.
course, it's my privilege to have you on the podcast here
Oh, thank you.
to
Thank
share
you for
some of
having me.
this too. It's really exciting stuff that you're working on, and of course, our connection is through the Hong Kong EdTech group here
Right.
locally.
Yes.
We're on the same WhatsApp group, and we've met at some local events here in Hong Kong. And so yeah, I've just been fascinated by this concept and the
Mm,
AI tutor thing. So we're gonna
mm.
we're gonna dig into all of this, but a word of caution. My audience is not super technical, I think. There's some, right? But we want to try to
Yeah,
not go too technical on some of the
for
explanation
sure.
here.
We'll definitely keep that in mind. Yeah. I mean,
Yeah,
I have experience kind of doing public outreach as well. And so it's always at the top of my mind, how to communicate
yeah,
science
yep.
effectively.
Good.
But thanks for the reminder.
Yes. All right. So first thing, your primary area of research has been in materials science, right? Looking at how we can use AI, machine learning to develop new materials. And now you've recently kind of crossed over into this math tutoring thing. So tell me how
Mm.
that kind of unfolded. How did you end up in math tutoring?
Yeah, it's quite interesting. So I'll go back a little bit. So my undergrad degrees, as you kindly mentioned in that long introduction, was I got a material degrees in material science and math, right? And so when I started my research in undergrad was quite varied as well. I did both experimental, which is how I discovered it's not for me, and theoretical work, which I really enjoyed, and I actually published the first author paper in undergrad that was on theoretical work. And so obviously I always really loved math. And I actually my first summer of uni, I came back to Hong Kong and I was a private math tutor. So, I have quite a lot of experience just personally, right, as a
Mm,
math tutor. And the connection actually, so when I started my PhD, I actually wasn't expecting or planning to be doing AI or machine learning research. I kind of given this background in like theoretical physics and using the math and physics and material science, I thought I'd be, doing things like condensed matter theory, materials theory. And the reality is funding is an issue. There's less money being funded. There's less, yeah, towards like more theoretical work, their focus is kind of proportionally because a lot of funding these days come from industry, and we can talk
yep,
about
yep.
that too later. Anyway, but it kind of worked out because I ended up joining the group I ended up joining. The project specifically that I was working on, as you mentioned, right, is using machine learning to help us design and make new materials. So it's not just about, computationally designing this material and be like, oh, this material should have these properties. It's like, okay, how do we actually make it? It's a huge challenge in itself. So I'm getting to it's all building up. So the the title of my doctoral thesis proposal was incorporation of domain knowledge in machine learning models. So the basic idea there is, as you and I'm sure most of the audience knows, right? These AI models need huge amounts of data to train, right? And this has always been the case. The issue is, what do you do when you simply don't have that volume of data? As is the case in material science, especially when you're working with like a very exotic material system, which is simply something that's really never been studied before, right? And it's expensive to get data experimentally, right, on materials properties. So the idea is that's where the incorporation of domain knowledge comes in. And what that means, in let's jargony terms, is simply quite simple, right? Like we as humans, we don't just learn by looking at a bajillion examples of things and like kind of picking up the patterns, right? We actually explicitly learn certain things like the laws of physics, the periodic table, thermodynamics. And these are the sorts of things that if we could directly and explicitly imbue machine learning models with, the idea is that that can allow the model to make useful predictions, right? With much less data. So that's kind of the main hypothesis, right? And so that's the sort of common thread with what I'm doing now with the math AI tutoring and more broadly in education. It's this idea of how do we explicitly encode knowledge into machine learning models? And I keep using this word explicitly because in a sense, like these models do have knowledge, right? I mean, we can kind of debate philosophically if they're just regurgitating and if that's true. But let's say, right, they kind of but any knowledge they have is sort of implicitly, right? Just again from these massive amounts of
Mm.
data
It's
and
patterns they've identified, not been
patterns they've
told
identified.
about, right?
Yes, exactly, exactly. Which is how, it can learn things incorrectly, right? That's what these, issues with hallucinations and like and more recently this whole it's been making waves. I don't know if you've heard about like this whole reasoning debate, which I have thoughts on. But anyway, the main issue is this knowledge that's learned, it's in this black box, right? And we always talk about these
Yeah.
machine learning models. It's in this black box. It's sort of impenetrable, right, to humans. Whereas if we're explicitly creating this knowledge, right, either incorporating it like by literally kind of hard coding it, but it's actually more interesting now. If we can learn this knowledge in a sort of explicit way in the form of knowledge graphs, which is sort of the key idea in the work I'm doing now, that can be really powerful because we can actually know at some, what's going on rather than just kind of needing to blindly trust this black box. So that's where, yes, so the knowledge graph encodes the mathematical knowledge, which forms a solid foundation for a math tutor rather than, right, again, it's kind of hard to trust just this black box thing, right?
Yeah.
Where you don't really know if it's, oh, is it going to add these, do this calculation, right? Is it just going to make up a false, theorem, right? Because that's the kind of thing that happens.
Yep.
So yeah.
Cool. So no, that connects the dots for me. And this is honestly, we had this conversation recently in Hong Kong, and
Yeah.
I think you got the sense that I'm really fascinated by this stuff and
I'm
this
glad. Yeah.
idea, right? And so we talked about kind of rules, right?
Mm,
That there was this evolution in the development of AI where, long ago, right, everything was kind of rules based, right? If
yes.
then else, right? Everything was
Mhm.
kind of very structured. And then when we
Right.
got to the LLM, though, it really became kind of unstructured. It was, as you say, this massive data and let it
Hmm.
figure out the rules. I'm not going to
Hmm.
tell it what the rules are. I'm going to let it
Hmm.
figure out what the rules are. And it's done a really good job in terms of language, right? It's given us the ability to be able to talk to a computer and it can talk
Yes.
back. We can have a conversation. It understands language. And so that's wonderful. It's amazing the stuff
Sure.
that it can do.
I agree.
Yes,
It
and
truly is.
yes, and it can now look at pictures and understand the pictures and
Mhm.
videos and stuff. It's amazing its ability to find the patterns and make sense of content we give it and
Mhm.
actually create content that makes sense or looks real. It may be
Yeah.
hallucinating, but
Yeah.
it's well, that's part of the problem, right? Is it's convincing. It looks
Right.
plausible. It may
Exactly.
not be real, but it looks
Exactly.
plausible. But now we're trying to layer in, right, this knowledge graph, if you will,
Mm.
that to me sounds more kind of rules based, where we're saying if this is true, then this should be true, which would mean this is true, right? And so we're giving it concepts to say, or building blocks, right?
Hmm.
But then we still layer into that at some point kind of the large language model,
Yes.
right? To
For
kind of
sure. Yeah.
formulate how it's going to communicate with me because it
Yeah.
understands language, right? So now
Yeah.
I'm giving it the concepts, but saying, all right, use the language model now to
Right.
explain it to the student. Is that
Right.
fair?
That is quite well summarized. I guess, our previous conversation, right? So a little bit on the history, right? As you mentioned, this rules-based stuff. This was kind of nowadays in retrospect referred to as one of the AI winters. So this is kind of the AI winter of the 70s and 80s. And interestingly, so I'm a bit of a science history geek. So if you'll indulge me, the reason for this is actually quite fascinating. So there were two scientists at MIT at the time. In those days, it was the AI lab. They later combined it to CS and AI lab, so CSAIL these days. But at the AI lab at the time, their names were Seymour Papert and Marvin Minsky. So Papert and Minsky. They published a very famous report. And actually, they also wrote a book that was published in which they expressed their skepticism that this new idea at the time, which is sort of the precursor. I don't know if they called it that at the time, but the it's the precursor to what we now call artificial neural nets. So this was a brand new idea at the time. And they expressed skepticism because they kind of made an assumption that kind of suggested their ability will be greatly limited. Now, obviously, that was wrong, as we now well know, because all of these
Right.
models, they're fundamentally they belong to this class of artificial neural nets, right? Whether you're talking about deep learning or LLMs or
Yeah.
all of that
So are you
transformers.
saying they hallucinated and it was plausible, so everybody believed it?
They I actually read the original report because it's all digitized and just available online, like in the MIT CSC cell file servers. They actually, to their credit, I was very interested in this one line. They said it's something to the effect of like, that being said, the fact that we don't really know anything about the properties of this is a result of, we lack any sort of mathematical understanding of these, again, what we now call neural nets. So they did kind of allude to the fact that, okay, yeah, we might be very wrong about this, but they were so influential. And actually, Seymour Papert is not just an influential computer scientist in the world of AI, but also in the world of education. So he's associated with a kind of constructivism and all of that for the educators out there. You can look into, very interesting guy. But that was why, right? So it wasn't so much hallucinated, but it was just, scientists are human. We make mistakes, right?
Yep.
And they were really the leaders in the field of AI at the time. And it was unfortunate, right, that they kind of released this really influential report. And basically what happened was the funding for the line of research of artificial neural networks basically dried up overnight. And that's when the expert systems, as we now call them, actually as they call them too, I think, were became the focus for about a decade or two in the 70s and 80s. And that's where you're talking about, right, these rules-based things, right? So it's not, one of the key ideas there is actually essentially we're very close related to what we talk about now with these knowledge graphs,
Mm.
right? They were sometimes referred to as ontologies, right? And you still sometimes hear that word, right, with things like the semantic web. But essentially, it was this hand-coded encoding of knowledge within some field is what's referred to as
Right.
an ontology. So there were like ontologies created for like the medical field and for I think like business world where they showed like the relationship between companies and like it would be like owner of company would be like a
Yeah.
node
A
owner of another
relationship.
company.
Yeah.
Relationships.
Right.
And these were
Right.
all hand coded
Right.
is the key. And
Explicit
that's what
is the
made
word
like
you used.
explicit.
Right.
So
Yes.
which has advantages because you know exactly what's in it. But the major disadvantages, which is why we now call this an AI winter, is because they were brittle. And the term brittle, right, in this context means that anything that's kind of slightly not what it was designed for, it just breaks completely.
Right.
Right. Like a vase, right? That just breaks completely. So
Yeah.
so
So you had to
and
think of
that's
everything.
why yes, and that's just impossible,
Yeah.
ultimately. And so they got like more and more complicated and become like intractable to like keep track of, and by like the 80s. And so that's why kind of in the 90s and early 2000s, in particular with the invention of what's called the back propagation algorithm, which is also a key, and this was this Yann LeCun? I forget, but this was kind of another major development in what makes modern AI possible.
Yeah.
But that was kind of the 90s and 2000s is when kind of these expert systems were abandoned.
Yeah.
And but let's jump forward a little bit to today, right? So we have so that's been the dominant paradigm, right? These artificial neural networks. And in particular, it was around 2014-ish, around that time, right? That's when I started uni. And that's when we rarely hear this term these days. Oh, you still sometimes do, but deep learning, right? That's when the deep learning revolution happened. And what deep refers to is simply the number of layers of these neural networks. So deep just meant there were a lot more layers than previously. And the reason that was feasible was the use of GPUs in the training. So
Right.
if people might have heard about like NVIDIA, like why are GPUs such a big deal, right? So for the audience, right, who might not know, the reason GPUs are such a big deal and crucial in modern machine learning is because well, GPUs, as you know, originally they're for a graphics processing unit, right? So what they do is, if you imagine like a game, right, rendering a game, they're made of loads of polygons, and you got to calculate like the vertices and the vectors and all that and the
Yeah.
light. And but there's like a ton of these calculations in any given scene, right? Like the number of polygons and
Yeah.
right. It's like in the 90s, they looked kind of so blocky, like the Tomb Raider, right? So the way GPUs are designed, right? You might know CPUs have multiple cores, right? But even now, like there was dual core like 10, 15 years ago, and then we became quad core, 8 core. Now there's even like laptops with, well, my laptop's 8 core, so I don't,
Yeah.
there are laptops with even more cores. But even a primitive, no, not primitive, even a GPU from like 15 years ago, it had hundreds of cores.
Mm,
But each core was kind of not very powerful compared to like a CPU core. They're very good at doing kind of a little basic calculation, but that doesn't matter because the key is it can do like hundreds of calculations in parallel,
mm.
right? That's what having multiple cores allows you to do. And someone realized, or uh, I don't know who, but around that time of the deep learning revolution was like that was kind of the perfect hardware architecture to do these neural network calculations. Because if you imagine, right, you have these layers of the neural net with, hundreds of nodes, but they're all in parallel, right?
Mm.
The calculations of like the updating the weight doesn't depend on the other ones. So you're able to simultaneously calculate these weights, you know? And so I don't want to get too technical, but that's
Yeah.
basically why GPUs are like, because you might think like, how are graphics involved, right?
Yeah.
I don't know if that was
I'm sure there are
you.
folks out there who question and wonder, yes, why did the GPU make such a difference? And that's a good explanation of it. Well, I think
Hmm.
the other factor here, just in general, right, was
Yeah.
computing power and availability of data,
Yeah. And
right?
data is the
Right.
big one. Yeah.
20 years
Data is
ago,
the
you
big
just
one.
didn't have the accessibility of all of that data that you need
Correct.
to train these models
Correct.
through that deep learning
Yes.
process.
So the
So,
combination of these,
right. So all these
the
things kind of
GPU, the
converged,
CPU,
and we got
and
large language models. I love these kind of stories of bravery, right? So you had
yeah,
this winter, but you still had people who believed, even though, right,
that's that's
somebody
that's true. Yeah.
authoritative, influential had said, no, 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 this is never going to work. You had people who
Hmm.
kept plugging away at it,
It
right?
did.
And then the
Exactly.
convergence of the data and the GPUs, and they found a way. And sure
Yeah.
enough, it did work, right?
Yeah.
It's not
Yeah. Yeah.
perfect, but it really took a leap forward in our ability to interact with computers. So this is brave. I love this. So I think what you're doing may also be brave, right?
Thank you. Thank you.
Because I'm sure there's
Yeah.
people out there going, what are you trying to do here? Why, you going back to
Yeah.
rules based or, explicit,
That's the
yeah,
that's the
stuff.
big thing. Yeah. Yeah. And it's a often used criticism. And so the broadly speaking, this approach, right, in a sort of expansive use of this term is neurosymbolic AI, right? Neuro referring to the artificial neural networks, this statistical, paradigm, right? Patterns-based paradigm, and symbolic, which again, in a sort of abstract way, right? Like it's not literally like just symbols and rules, but like rules of logic, but that's a part of it. But to me, it's also just about like the discrete nature of things. So like a graph, right? That's discrete. You have
Mm,
individual nodes and things rather than just sort of this continuous weights in this fuzzy kind of probabilistic
yeah.
network. And to me, the power is from combining these two, right? And I'll share a little bit why. I'll try to make a case for why I believe this is
I think we've
promising.
talked about a lot of pretty ethereal things here.
Yeah.
Let's get a practical example. I don't know, can you use the one of the adding fractions example that's in
Mm.
your paper? Can that help kind of on why an LLM struggles to take a student through a math problem like, say, adding two fractions together and where you're trying to go with this model and why it's so much better? Can we do that?
Yeah, I think this ties in nicely with kind of what I was about to get at, right? Which is that the way our human brain works, right? And this became this kind of became popularized as a concept because there was that book that went quite right, the Thinking Fast and Thinking Slow,
Mm,
right? And what that's about is these two complementary systems that we use, right, in our brains, right? It's called
the
system one and
conscious and the
system two.
subconscious, right? System one, system two. Yeah.
System one, system two, exactly, right? I
Yeah.
mean, there's sometimes like slightly, but yes,
Yeah.
essentially, right? Where there's the system one, which is the fast thinking, right? That's the one that's patterns based. That's the one where And I think this is the perfect example, right? When you're speaking a native language or a language at least you're very fluent in, that's kind of subconscious. You're not consciously thinking of every single word that you're producing, right?
Mm-hmm.
And that's very much like an LLM, if you think about it, right? They've learned the patterns and the rules of language. They're very fluent in producing language,
Mm-hmm.
right? But, you know, just like us, like when we, and it's necessary that we have the system on, right? We would, our brains would, overheat if we had to consciously think of every single action we make every second of the day, right?
Yep.
So this is
It's
evolutionary.
exhausting. Yeah.
Exactly, right? And but we are aware ourselves of like some of the limitations of this, right? We know what illusions are, right? When you kind of just, right, like optical illusions or auditory,
Right.
like all of these things happen, right? Which is why, and that's sort of comparable, to hallucinations and LLMs.
And
And
biases,
that's
right?
and biases.
Yep.
Yeah, subconscious
That's
biases. Some
subconscious
we
bias.
have
Yep.
to consciously be like, oh, like I shouldn't, that's not right.
Right.
But which is why, so we have this complementary system too, right? And that kicks in when we're, as you gave the example, when we're solving a hard math problem, right? Which, to a kid, fractions are hard.
Yes.
And also when we're just, when we're, for example, crafting an argument, right? Kind of logically laying out these steps, doing complex planning,
Mm,
right? These things all involve sort of explicit, conscious, slow thinking, as they call it,
mm,
right? And so that brings us maybe to this concrete example, right? Where these LLMs, they're designed, it's in the name, right? Large language models, right? I mean, yes, there's multimodal things now, but by and large, right, they're based on like understanding these language patterns, right? Which is why, like you said, it is amazing, right? I always like to remind people like all these models are doing is predicting the next word or token, technically, which can be part of a word, right? They're literally like like given this block of text, what is the most likely or the best like next word that comes, and it generates the next word, and then it feeds that back in to itself,
mm,
and it generates the next word, and it feeds that back in, and it's frankly amazing to me how well it does doing just that. But like we said, these languages are incredibly fluent and are you know, seem to us, right, that it kind of gives the illusion of like it's like really eloquent and like thoughtful or
yeah.
but ultimately that's all it's doing. It's predicting the next word. So, I think that's amazing, right? But we have to recognize the limitations of that,
Mm,
right? And so that's why these models struggle so much with seemingly extremely basic tasks, like adding fractions or adding two-digit numbers together. Like LLMs will get that wrong still
mm,
consistently, right? The famous one is counting the number of R's in strawberry, you know? Like that's like the example that always gets used, and the reason for that is because it's kind of the wrong tool for the task,
mm,
right? It would be like asking us to like count the number of, things in something, and you're only given a glance at it, right? So you just kind of get an impression of, oh, like roughly like how many there are.
yeah.
Whereas the correct, the actual tool, the system is the slow way, right? In particular with like counting, right? Like humans, we have it's called subitizing, and we have a limit to like how many we can instinctively pick up. And it's like around 5 or 6. Anything
Yeah.
beyond that, we have to count explicitly. So that's sort of just one example of how these are two complementary systems
Yep.
inspired by biological intelligence, right? Our own brains.
Mm,
And that's the case I make for like why I believe combining these two paradigms, the statistical and the symbolic paradigms, is such a promising avenue to at least explore, right? I think, I'm not saying for sure
yeah.
this is going to work but like you said, there's a little bit of bravery involved, right? To try something different from
Yeah.
what the majority of AI is doing right now.
All right, let's take a quick commercial break. I want to plug the human intelligence movement. No, this is not a paid advertisement, just me wanting to support this organization that I think is doing really, really good work. So the mission of the human intelligence movement is to ensure that students have the skills to thrive and succeed in an AI world. So join the movement. There's a link in the show notes. Now, back to my conversation with Haihao Liu. We're just getting to the really good stuff. Thinking fast, thinking slow, system one, system two brain, and how they're trying to really model both sides of this, the fast and the slow, using knowledge graph-based AI combined with generative AI, large language models, or LLMs as we know them. So let's keep going. Right. So like an LLM in this example of the fractions, right? It sees the pattern of how to solve it. It knows what the steps are, but it doesn't know the kind of the why, right? It knows you should add these two numbers together or multiply, to get a common denominator. It knows you should do it, but it can't really explain the why, right? And so sometimes it may just get it wrong too, because it's thinks it's seen a pattern of how to solve this thing that isn't
Mm.
really the right way to solve it.
Right. Right.
So, but this thing you're working on, right, kind of
Hmm.
slows down and looks at the concepts and goes, oh, there's addition involved in this. There's multiplication involved in this. There's these operations which it's been explicitly told how to do. So now, and I love this part of what I read in your paper, right? It's ability to kind of step back and go, okay, what do you know already?
Hmm.
Right? Kind of
Yes.
check the student and go,
That's the
okay,
key.
right?
Yeah.
Do you know how to add? Right? Do you know how to multiply? Because you got to be able
Right.
to do those things before you can do this, right?
Exactly. Yeah.
Yeah. So
Yeah.
talk
And
to me
that's
about that.
inspired.
Yeah.
That's my inspired by, my own and and my co-founder. We had quite a lot of experience as a human tutor, right?
Yes.
And what we noticed, from our experience and also from our side as like students throughout our lives, right? That kind of the best teachers really try their best to understand, the student's perspective, like what they know and don't know, right? I
Mm.
mean, we might call that empathy. We might just, it's and and that's a hard thing, right? Even for humans, right? That's why I said like kind of the
Yeah.
best teachers, right? Try to do this and are able to do this. And so that's one of the key hypotheses that we're exploring with this research, right? Is that can an AI model through asking the right questions of the student, right? Like asking a student to do a certain problem, seeing where they make a mistake, or sometimes even just literally directly asking, "Do you know like what this is?" And
Yeah.
the student blanking, right? Then like, okay, we need to start there.
Yep.
That's the kind of thing, right? But again, it's a difficult thing, again, even for humans. So this is certainly ambitious what we're trying to do. And and to your point of like the slowing down, right? That's right. That's where the kind of this other system comes in, right? Like we kind of want to go back and forth, right? Where again, the language and the the empathy even, right? Like the try and form a connection with the student, that's very important too, right? We
Mm.
know as teachers, that's what LLMs do well, right? We know this, right? People are slightly concerningly, right? Because sometimes these tools aren't designed for that, but people are kind of using LLMs for emotional support and essentially as a therapist. And there have been some tragic cases, which we won't go into, but but that's proof, kind of, right, that these LLMs are able to tap into our emotional and kind of language as a form of connection, right?
Mm.
Which is really good at. So we leverage that. But when it comes to like doing the actual math problem, right, or like explaining the step by step of how to do something, it's not very reliable at that, right? So what we use is we use a system that we know is reliable. Something like, for example, right, this is kind of this would also fall into the neurosymbolic paradigm, would be, having a sort of plugin, right, of like Wolfram Alpha, which I'm sure most people are familiar with, right, with the online tool that, you can put in a math problem, and actually much more than just math problems now. And it gives you like a step by step, and it's guaranteed to be correct, right? Because it's built on the mathematical language, right? This formal
Mm.
language, and like when you punch something in a calculator, you don't expect it to like 1% of the time, be off, right? It will
Right.
always be right,
Yeah.
right? And so and that's what we need in this instance,
Mm.
And so that's the equivalent of the slow thinking of like our brains, right?
Right.
And we need both of these,
Right.
right?
But except
The
to,
language,
so
yeah.
there's another layer in there though in education, right? And that's this kind of,
Hmm.
Socratic approach that says,
Yes.
don't give me the answer, even though you know the answer,
Yep.
right?
Yep.
Don't tell me what it is.
Yep.
Somehow you got to get to this interrogation almost of the student, right? Do
Yeah,
you
yeah,
understand why,
yeah.
this step and then this step and then this step, right? And so you got to be constantly kind of asking back, right? Why do you want to
Hmm.
do that next?
Mm.
Or what do you think you should do next, right? So this is hard to say.
It is.
It's really, really hard. So, but I want to get to, because we referred to this multi-agent
Ah,
IL plus RL, right? So
yes.
IL is imitation learning,
Imitation
right?
learning. Right.
Yes. And RL is um, reinforcement
Reinforcement
learning.
learning. Yeah.
Yes.
Yeah.
Okay. So talk to me a little bit about that, because this is really
Yeah.
important in this model. If you're going to be explicit, you got to
Yes.
imitate somebody who is an expert, right?
Yep.
So how are you
Yep.
doing that now?
Yeah. So reinforcement learning is the more widely known term. And I'll be fully
Yeah.
honest, I only came across imitation learning as this, explicit technical
Yeah.
term a few months ago. And I was like, oh, I read this paper and they suggest in the paper that the combination of imitation learning and reinforcement learning is a very promising area for future research. So I was like,
Good. Yes.
but reinforcement learning, as you know, so it's how, for example, AlphaZero, AlphaGo was trained, right? It's actually also how these models are sort of fine-tuned to produce less harmful content. That's like reinforcement learning with human feedback. But basically the idea is like, any output or action it takes, it gets some reward, right? And it's trying to like basically maximize that reward, right?
Mm.
So in the game of Go, right, it's trying to like, the board gets assigned some like score of like how winning of a position you're in, right? And it's just trying to like
Yeah. Yeah.
maximize that until it wins. Imitation learning is sort of complementary because like with reinforcement learning, it's kind of funny if you ever watch those like animations of like reinforcement learning on something like trying to learn to walk. It's like the first few iterations, it's just like spazzing,
Yeah. Yeah.
because it's just sort of random, right? But some of those random movements are the reward for that is like it's towards the
Right.
desired
Right.
behavior, like walking.
Yeah.
So, but you can see how like for certain complex tasks that can be like very difficult because you might not ever randomly hit upon like the right
Yeah.
moves, which is where
Well,
the
isn't
imitation.
another example though,
Yeah.
there's actually been criticisms of some of the big, open AI and whatever, that they
Mhm.
used like masses of people, right?
Mm.
To like for images, right? So to tell the models you're getting it right or you're getting it wrong. So they used people to do reinforcement learning to tell the
Yeah.
models when they're getting it right, when
So
they're getting it wrong. Isn't that part of
yeah,
reinforcement
so
learning?
I'll have to check that. So I know like because there's kind of two ways you could do this, right? With just kind of like the standard. So there's kind of there's like supervised learning, unsupervised learning, and reinforcement learning. Often machine learning gets that's
Okay.
split into these three. And the human part that could be supervised learning, where they're literally just like labeling. So like when this was kind of reported on, drew a lot of criticism, right? Of like when you report like very violent or harmful content on like social
Mm.
media and stuff, that gets sent to these like workers in often in very poor countries like in Africa. And these workers who are just literally every single day just nonstop showing these like terrible, violent or like, and
Yeah.
it's anyway, so and that they're kind of just like labeling like for future training, like is this actually violent?
Right.
But it could also be so in a reinforcement learning context, that would be like the human is providing the reward, right? So they're judging
Right.
like, oh, is this action kind of more like walking or something, right? Versus right, and that's
Yeah.
because it can be very difficult to program a reward function, right? To like have a function to say like, oh, this is better than that,
Yeah.
right? So, but these are all, yes, so these are all kind of challenges or limitations of reinforcement learning, right? Because here what we're trying to do is essentially learn the behavior, quote unquote, of an expert tutor or math
Mm.
tutor, right? And so, you're certainly not going to want to just like have it say random things, right? Obviously, it won't be random, right? But it
Yeah.
might just give you the answer, right? Which we don't want. It might kind of explain something's not clear, but or make us some. So
Yeah.
what we do is we start with an sort of imitation learning process where we use examples of human expert tutors, right? And how they interact with students. And as a sort of, and you could think of this as like fine-tuning the language model or this imitation learning, right? It's slightly, subtly different. Actually, I'll have to explore more myself, but but that's the idea, right? So that's why we're combining these. And I think you touched on you asked like how are we going to do this? Where are we going to get this expert? So
Yeah.
that's kind of the our business model, if you will. So the kind of stage one of this project is actually just recruiting and having human tutors. And our plan was to kind of use my connections with MIT and Harvard and to recruit undergrad students. And you know, many of these students at these schools, they have experienced tutoring in high school, you know,
Mm.
to earn a bit of, you know, pocket money, right? Instead of mowing the lawn, they
Yeah.
do a bit
Yeah.
of tutoring. And so we think we can attract undergrad students as tutors, especially because as our market, we're gonna tap into Hong Kong's tutoring market, which is, you know, is very, yeah, very competitive, but also very high demand, you know,
Yes.
especially
Yeah.
and so and the hourly fees that you can charge, right, from, you know, these
It's
quite
expensive.
affluent,
Yeah.
they are very expensive,
Yeah.
and especially compared to like in the US, you know.
Yeah.
And so we're that's our, you know, I'm
Yeah.
less on the business side of things, but that's kind of our
And
idea.
there's a tutoring center like everywhere.
Oh yeah,
You know, yes,
exactly.
I walk through the mall in my building here,
Exactly.
and yes, I think there's four of them just in our complex. Yeah.
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 Yeah. And so that's our hope. And so, you know, you know, the idea is to one, we're hoping like, you know, having MIT, Harvard in there is
Yeah.
was the selling point. And we will charge less, right? Because again, even if we charge less than kind of the Hong Kong standard, it's still more than the kind of hourly rate in the
Yeah. Yeah.
US. So, leverage that. And we're also trying to make the online tutoring part a selling point actually versus because people think, oh, in person is always better. And you know, it's true in some ways, but also there are actually advantages of online. So for example, you can record the session and the student can
Mm.
go back and watch, you know, a part that they're like, how did they solve that problem again? You know,
Yeah.
that's an advantage. And you know, you just be on an online platform, you have access to like videos or tools, right? Just like right
Well,
there.
and accessibility.
Yeah,
Yeah.
and
Yeah.
obviously in this case, the students will, you know, be based in the undergrads, you know, tutors
Yeah.
will be based in the US. And
Right.
so,
Yeah.
you know, just a matter of like practicality, we have to do this, but also we think like, you know, there are advantages to this too.
Mm.
And so with, you know, we have to consult legal on this, but like with like full data, like consent and kind of data protection, that kind of thing, we would record these sessions, right? It could even be like, you know, depending on what the students come to, it could even be just like the transcript because at least initially, like these models will be like text-based, right? Before
Mm.
we kind of try to do like, you know, multimodal like voice interaction. You just
Right. Right.
ask it. Initially just be text-based, right? So even transcripts would be helpful. But if we can record like the audio and the video too, we could potentially even do things, and this is just kind of, you know, brainstorming here at this point, right? Like there's like sentiment analysis. Can we see on the student's face like they don't get it? You know,
Mm.
sometimes they don't verbally say something, but you can just tell by their expression, like
Yep.
they're lost,
Yeah.
you know? And that's the kind of thing that we could explore too. So that's the idea. It's yet to be validated, I guess, to use the entrepreneurship term, but
Yeah.
we're
Well, I was
making
going
the
to
plan.
ask, it's one of my questions, right? So where
Mhm.
are you in the development and when
Yeah.
can we expect something that's actually available for folks to start
Yeah.
using?
Yeah, that's the million-dollar question, potentially literally, you know, if we're applying for
Yeah.
grants.
Yeah.
And so, you know, we recently, as you mentioned, the proposal that you read, right, that was submitted for a call for proposals from this AI company. They're based in Abu Dhabi, UAE, called
Okay.
AI-71. They produced these models called the Falcon models, and they were a little popular a while back, but not so much these days. But you know, it's and so we received some funding in the form of basically compute credits, so we can use
Okay.
their models and their you know their compute infrastructure
Yeah.
to do some training on those models. And yeah, so that's like it's very nice, but it's like
Yeah.
not real money, so I
Right.
can't
Right.
pay myself. And so we're at the moment, you know, generally speaking, you're saying the ideation phase, right? Like we're working on building an MVP, and the challenge is like the long-term idea and the research, right? And that's why I introduced my, you know, it as a startup slash nonprofit
Yeah.
because
Yeah.
like I want to do research, but that's a little bit incompatible with kind of the funding and the startup and
Yep.
stuff. So we are trying to do a bit of both and get funding and then do research on the side while also so we're figuring that out. But we're going to be applying to things like the Cyberport or the STP ideation programs, incubators,
And the
and
startup is based in Hong Kong. Is that right?
yes, yes. We and actually for these programs, for the like earliest stages ones, they actually help you with that, the registration process and
Right,
stuff
right.
in Hong Kong. So,
Yep.
um, so yeah, so in short, big ideas, still working on bring those ideas to reality. But we've had, in terms of traction, I've had after we got this funding, I post about it like on social media and like on my various channels of, AI researchers and whatnot. And we've had quite a few people, about a dozen or so people like reach out, just expressing interest
Mm,
in helping or joining the project. People with, software engineering backgrounds, people who can help with like ops. And I always explain to them, like right now we have no money to pay
yep.
you. So this will be, voluntary slash maybe like equity, position. But people are interested because I think they do find the idea interesting, right? It's
Yeah.
certainly quite different from I don't want to sound disparaging, but a lot of what's out there at the moment, right? Where the term that gets used, and I don't like this term because I think it's kind of silly, is like deep tech, right? Like we're kind of doing something deep, whereas, right, rooted in real like fundamental research,
Mm,
right? Whereas others are more really application based, right? We're just kind of taking what already exists and just building some top of it, which there is still value. Again, I don't want to sound
yep.
disparaging, really, but also there's a balance because I think there's a lot of just
Yeah.
like hype out there too.
Well, I've always said, the things that are of the most value are the things that are really hard to do. And it sounds like what you're attempting to do is really hard, but so
I
it
will
may not
not
come
deny that in the
quickly.
least.
Right. It may not come
Will not.
quickly. I wasn't
Right.
expecting you to say, "Oh yeah, in 6 months we're going to have this fully baked," right?
Yeah, yeah.
No, but
Well, think about the MVP though. Like, what can we like a minimum viable product? Because we can construct like a basic knowledge graph and like as a proof of concept, right?
mm,
You can kind of it's not literally hand coded, right? But you can kind of build a knowledge graph from essentially rules-based things, from collecting. It's actually quite a cool idea. It's quite simple too, so and elegant. So
okay,
I'll just say, on like Wikipedia, for example, you look at the, which has loads of articles, right? And you look at kind of the introductory paragraph or the introductory section
right?
of an article, and they have a bunch of links, right? And the idea is those links are going to be the topics, most related to this article,
Yeah.
right? And so you can construct in a very quick way, computationally speaking, right? A knowledge graph of the relationships between like topics or
Yep.
articles on Wikipedia. And that
Yeah.
can be a starting point, that can certainly be a starting point. And then as part of this proof of concept, right? Like some of the basic hypotheses we're testing of like, oh, given this knowledge graph, or given say like an incomplete knowledge graph, as would be the case with a student, right? Like how can we actually modify like what the language model is decides to say next, right? Because it's like, oh, I see the student is like missing this concept, right? Okay, so instead of asking the student to like do this problem, I'm gonna instead ask it like to do a problem that like tests whether they understand that thing, right? Or
Yep.
even
Yep.
just showing things like that, right? So
Yeah.
there are certain things we could try to do in the short term, and we really kind of have to for
Yes. I
purposes
was
of
gonna say, yeah, you have to.
yeah, yeah.
And
But in terms of the long term, I have no shame in saying I'm very much an idealist. And if you look on my LinkedIn headline as well as the tagline for like Turn the Education, I say education for the 22nd century. That's
mm,
why in the intro you read, right, I talked about in this century and beyond, because I really, my view on education in general is that it is such a long-term project. Like we look at like what education reformists, progressive like Dewey and Alfred Northhead, I quote, 100 years ago even, and they were saying things that like would still apply today, like
yeah.
Northhead was quite critical of like overly testing, and but that being said, there is progress being made, right? It can be sometimes hard to see because it's so gradual, but I'm biased, but I did IB and I think IB is an example of, they're doing not everything perfectly, of course, but they're doing some lots of things
Sorry,
right.
for our US folks who don't do
Oh,
IB.
yeah. The International Baccalaureate,
Yes.
right? Yeah. And it's like you said, I really like that, and it's quite encouraging, right? Like this idea of like you have to have a certain level, kind of bravery, right?
Yeah.
To to do something ambitious and to do something different because it very well might not work out. But that's the nature of research, right? Which kind of given
Yeah.
my background, that's kind of the part for the course, right? Where like unlike in business and startups, it's like, oh, you have to succeed, otherwise you're,
Yeah.
but the reality is, of course, a lot of startups fail too. But in
Well,
research,
learning, yeah, learning anything out of this is success, right?
that's true. Yeah.
Right.
And that's how it's not the success shouldn't be measured by, oh, like, what's our AIR or like what's our, how much
Yeah.
money do we raise for me personally. So I think, yeah, I'm like I say, I'm a bit of an optimist, but I think we need a bit of that, right?
Well, you have to believe in what you're doing.
Yeah.
Um,
Yeah, yeah,
and,
yeah.
and well, I get it. And I love the passion. You're a super smart guy. So I
Thank you.
have faith that you're going to figure something out here.
Something out,
And,
yeah.
my guess is, this is how this stuff goes, right? It won't be perfect, but you
Hmm.
may move us forward and hopefully demonstrate that there's promise here, right?
Hmm.
That
Yeah,
with enough investment in time and the right people coming together with the right resources, that it's something to build upon. And
yeah,
if you
yeah.
accomplish that, that's huge,
Oh,
right?
that would be, yeah,
Yeah,
for sure.
yeah.
For sure.
So awesome. Well, anything else you wanted to add? I know we're at about an hour here.
Mm, Not really. I guess I'll just echo a bit of the message that I was trying to share at the
Yeah,
panel to all these
yeah,
business and government leaders on Monday, which is that given all this discussion today, right, my view is that we can't forget the recommendations and the lessons that were taught that we learned sort of in the 20th century regarding research or basic research. And I quote Vannevar Bush, who was a vice president of MIT and the first, I forget the official title, but basically the scientific and technology advisor to the president of the United States, like that
okay.
position was created. So he published a very famous report. It was commissioned by FDR, but who passed away, so it was ultimately delivered to Truman. And the report was called Science. Wait a second, it's not the last frontier. Science, the endless frontier.
Ah, okay.
and and it was quite a famous report because that was the report that led to the creation of the National Science Foundation in the US, which is
Mm,
still the largest funding institution, despite the increase in industry, but there's still the largest funding for kind of basic science research in the US. And I was funded by the NSF as a PhD student, as I
mm,
mentioned in my intro. But the message that I want to echo from Vannevar Bush in that report is that we need to fund not only kind of the applied sciences, right, but also basic science. And I've been saying this word, but maybe I should clarify, like, what is basic science, right? Basic science is kind of research that goes to just purely for trying to understand something rather than trying to create a certain technology or a goal, right?
okay.
So a recent example of this is the mRNA, right? When the scientist, she's from Hungary, she did this research back in the 80s, I think, and or 70s, and it was at the time there was no one foresaw any practical use for this. And she actually had a lot of trouble, getting funding and she was discouraged by all her, colleagues. And then look what happened, 40 years later, we had this terrible pandemic, and that was the thing that saved us. And that's the kind of thing, right? Where the idea is, to go back to the refrain today of like, have a bit of bravery, and you have to be, take a bit of a risk, right? And so my message is like the government, right? Both, in the Hong Kong and the GBA, but also just like China. And really, I'm not, I'm a global citizen, right? So I
Yes.
give the same recommendation everywhere. Like we need to remember that, right? In a world where a lot of it's driven by business interests and like, oh, what's the next app or what's the next tool that we can develop? Sometimes we need to remember like the biggest world-changing discoveries happened because we weren't trying to create something in particular. We were simply trying to expand the frontiers of, human knowledge.
Mhm.
And the return on investment in that is incalculable in many cases. So that would be my kind of parting
Well,
message for
that's a
a thought
powerful message there. I agree.
for thought.
Yeah.
Yeah.
Yeah. Yeah. We need to be brave. We need to expand our understanding.
Yeah.
Yeah, exactly. So, well, good for you. I hope I can support you in some way
Thank
along
you.
the way
Thank you.
here. When are you back in Hong Kong?
Oh, just in a little over a week, actually. So
Okay, I'll be
I
in
will.
Thailand in a little over a week,
Okay.
but
Well, have
but then
fun.
I'll be back. Yeah,
Yeah.
just a week later. So
Hmm.
yeah, so keep me updated on your
Definitely.
progress. Of course, I'll watch for your notes on that WhatsApp group.
Yeah.
Great about posting stuff there, which is good. So yes, keep sharing that knowledge with all of us, all those connections and interesting things you come across. You
Yeah.
clearly
Yeah.
read a lot and are well connected. So yes, always great to hear from you.
Thank you. Thank you.
Yeah.
Well, thank you so much for having me, Eric.
Yeah, no, this has been fun and I've learned a lot. So that's if nobody else does, I did. That's good.
Glad. Glad.
Yeah.
Well, thank you for the great questions and the conversation.
All right. Thank you. I love the bravery to explore an emerging area of research while simultaneously launching a startup to test the practical application of what they're learning from the research. So I'm also impressed by the interdisciplinary effort here. So this involves a combination of the neurosymbolic AI with machine learning and of course, neural networks and large language models, but also learning science to develop this AI-powered math tutor that will be able to understand a student's knowledge gaps and individualize tutoring to meet their needs. The idea that an AI can actually learn from human math tutors to develop knowledge graphs that map the concepts involved in solving math problems well, this just sounds brilliant to me. And I'm really, really hoping that Haihao and his team are able to pull it off. So, I'm Eric Byron. Thanks for listening to the Education Innovators Podcast. If you haven't subscribed yet, please smash that button. We have so many great guests lined up with amazing stories of innovation and education you don't want to miss. Be brave, keep innovating. You are making a difference.